Welcome back, guys. Let's make sure that we can apply the rules of probability to some practical problems. Now, one of the most common things that you will get asked in a test or an exam or to even do an investigation is playing cards. But just make sure you've got all the big details of probability in front of you. So it's very important that you revise often the concept map that we've been dealing with. We're going to try and make sure all of these details are things that we can explore in our little game with the playing cards. So we're definitely going to look at theoretical probability at Venn diagrams, at two events, union, intersection, and whether things are mutually exclusive or not, and apply the OR rule. So here's our little situation. We've got a deck of playing cards that contains 52 cards. So there are 52 cards in this deck. They are ordered in 4 suites. Now we have the hearts, the diamonds, the clubs, and the spades. Remember, the hearts and the diamonds, these are the red cards, and the clubs and the spades are the black cards. There are 13 cards in each suite. So you've got 13 hearts, 13 diamonds, 13 clubs, and 13 spades. That all adds up to 52. The sample space in this situation is 52 cards. So please remember that. We're going to need it as we go forward to the questions. So we're told this, that one card is selected from a deck. The deck has 52 cards in it. What is the probability of selecting a red card from the deck? Guys, this is so easy. We just have to apply the rule of defining theoretical probability. Do you remember what that is? That's right. We're going to say the probability of choosing a red card from the deck is equal to the number of red cards that we've got divided by the number in the sample space. Now, if you remember, I said to you there are 4 suites, and in each suite there are 13 cards. There's a suite of hearts, which are red. There's a suite of diamonds, which are red. So 13 plus 13 tells us that there are a total of 26 red cards. So the number of red cards is 26. And the number of cards in the deck is 52. And so the probability of choosing a red card from a deck is 26 out of 52, which is 50%. It's 1 in 2. You've got a chance of either choosing a red card or a black card. The ratio would be 1 to 2. 50% probability, or we can write it as 1 over 2. That was easy, and I'm sure you've got it. I'm sure you're with it. Let's step it up a level. Let's ask our next question. So we're told that one card is selected from the deck. What is the probability the card is a heart or a face card? So what do we mean by face card? Well, a face card is something that is either a jack, a queen, or a king. It's got a face on the card. We can see what it looks like. It's one of those high value cards. So the jack counts for 10, the queen counts for 11, and the king counts for 12. Some people do it in that notation. So what are we asked here? We're asked to look at 2 conditions. We're asked to look at 2 conditions. And the first condition is that the card is a heart. So we want to know what is the number of hearts. And my heart isn't very clear there, but I'm sure that you can recognize that the number of hearts in the deck is going to be 13, because they all belong to the suite of 13. Now, if we ask the next question, what is the number of face cards? Well, that's a little bit more tricky. Remember that there's jack, queen, and king. And we recognize there are face cards for the hearts, for the diamonds, for the spades, and for the clubs. So we recognize that for each of the 3 suites, the face card, there are going to be 3 face cards times 4 suites, and that is going to give us an answer of 12. Now, do you notice something as we've counted those out? Are there elements that are common or not common to both of those 2 groupings? I think you can see, just by doing the counting, that there are 3 cards that are both hearts and face cards. So to make this a little bit clearer, I think it would be useful to draw a Venn diagram, just to illustrate it a little bit better. And I'm going to draw my Venn diagram up here. So in my sample space of 52 cards, I'm going to write the ones that are the hearts over here, the little hearts, and I recognize that there were 13 of those, and I recognize on my face cards, these ones were the face cards, there were 12 of those. 9 of them are individual, 3 of them belong in the intersection, and what do we recognize that we've got over here? There are 10 that are not face cards that are still hearts. Okay, so we're almost ready to do the calculation. Recognize that this situation is a situation where the 2 sets are not mutually exclusive because there's an intersection. So what are we going to do? If we are going to calculate the probability, we're going to say the probability of the heart, and I'll just do it as H, union face card is going to be equal to, because it's not mutually exclusive, we recognize it's the probability of the heart plus the probability of the face card minus the probability of the intersection of those 2. So it's the intersection of those 2. So very quickly, what do we recognize? We know that we had 52 cards in total, so the probability, the number of heart cards is 13 out of 52. We know that the number of face cards was 12 out of 52, and we know that the number in the intersection is going to be 3 out of 52. And when you add all of those up, use a calculator, you will definitely find the correct probability of choosing either a face card or a heart. I hope you can see that we've applied the rules. Very quickly, I want to just summarize and recognize the key points that we've gone through. The sample space, don't forget it. Recognize that the sample space, or the probability of choosing something from the sample space is 1. Recognize what relative frequency is. The complement relationship is important. Union intersection, we've done it. And then the idea of mutually exclusive. And finally, our rules that apply to when things are not mutually exclusive. Guys, I hope you recognize all of these rules. And remember, probability rules for sure.